Throughout this video, we're going to do a desktop computer dissection using 3D animation, kind of like a dissection lab in biology class, but instead, we'll journey through the inside of this computer and disassemble every piece of hardware. We'll then use a microscope and zoom in to give you a nanoscopic view of the transistors and other structures inside. To make this video, we disassembled all the hardware inside a typical desktop computer. We desoldered and removed the components from each of the printed circuit boards and took thousands of pictures. Then, using these pictures, we meticulously 3D modeled every single component from the computer case down to the tiniest resistor. As a result, here's all the hardware that we'll explore throughout this video. It kind of looks like a crime scene where someone viciously destroyed a computer and arranged all the components. But anyways, let's dive right in. We'll begin this journey with the Central Processing Unit, or CPU, which is the brain of the computer. On top, we have the cover, called an integrated heat spreader, and inside is a smaller metal package that holds the integrated circuit, which is technically called a die. This die is mounted on a printed circuit board that distributes the 1200 connection points to landing pads that interface with the landing grid array on the motherboard. The integrated circuit inside has a few different sections, but perhaps the most recognizable are the 10 cores where programs and instructions are run. Each core is quite complicated, so here's a diagram laying out the different functional sections. There are dozens of rather complicated elements in this diagram, and you can look forward to a series of videos we're currently planning which will explore computer architecture and how each of these sections work. Let's zoom into a nanoscopic view of the integrated circuit so we can see individual transistors. These transistors are incredibly small, only a few nanometers wide, and in this die there are approximately 8 to 10 billion. On top of the transistors are multiple layers of metal wires, with vias rising vertically between the layers. Together, these transistors and wires create a multi-layer labyrinth or highway, resulting in a computer that can execute billions of operations every second. Let's now zoom out and look at other sections of the CPU. To the side of each core is the shared L3 memory cache and ring interconnect. On the far right is an integrated graphics processor which functions as a less powerful GPU. In the top left is the memory controller which sends data to and from the DRAM. And finally, on the far left is the system agent and platform I/O, which communicates with the chipset on the motherboard and manages the flow of data between many of the other components in your PC. So with that in mind, let's move on and look at the motherboard. This motherboard is a massive printed circuit board with thousands of wires running inside and a variety of microchips, components, sockets, ports, slots, headers, and connectors soldered to it. Perhaps the single most important and expensive component, aside from the bare PCB, is the chipset, which is this integrated circuit found underneath a heatsink down here, and is connected directly to the system agent section in the CPU. Here's a diagram illustrating how the CPU and chipset are connected to everything else. As seen here, the CPU connects directly to the DRAM, one or two displays, the GPU, and perhaps a few SSDs plugged into the M2 slots. The chipset manages most everything else: data flowing through the Ethernet or Wi-Fi, data going to and from solid-state drives and hard drives plugged into the SATA ports, some of the PCIe slots, your keyboard and mouse, USB devices, and the audio sent to the speakers or from the microphone. Just a quick note. Computer hardware has evolved immensely over the past 65 years and continues to evolve. So the details we show should be thought of as a current-day example PC and not as how all computers work. Let's move on and skip over the many different sockets and connectors throughout the motherboard and focus on the voltage regulator module, or VRM, found near the CPU. These components are used to drop the voltage coming from the power supply down to the 1.3 volts used by the CPU. As a result of all the power flowing through these components and their 80 to 90% efficiency, heat sinks need to be placed on top. While we're on the topic of power, this CPU consumes power equivalent to approximately 16 LED bulbs, thus generating a considerable amount of heat, which is taken away by the CPU cooler. This particular cooler uses a pump to circulate liquid through these tubes and into the radiator's channels, which transfers heat to the radiator fins. The fans then help transfer the heat to the air, and the cooled liquid returns to the pump via the return loop. The pump is a brushless DC motor constructed from a PCB, a control chip, and a stator on the dry side, a barrier in the middle, and then the permanent magnet rotor and impeller on the liquid side. There's no mechanical connection between the rotor and stator, thereby preventing any leaks of the cooling liquid. Let's move on to the power supply, which distributes power throughout the computer.